Meteorologist Joe Bastardi, whether or not today we're going to take a brief look at water vapor and my water vapor theory. There's a lot of yelling and screaming that's going to be going on because you see, okay, I'm a volunteer strength coach for the Nittany Lion Wrestling Club. The guys that have graduated. Can't monkey around with the guys in school. The guys I was helping out had a workout this morning. So I'm over at the wrestling room. And there's yelling and screaming going on. So, but don't mind that. I mean, if you're going to look at this face, what do you care if you hear some noise in the background? All right. Now, I want to show you my step-up theory of global warming. Okay. And it all has to do with water vapor. All has to do with the oceans, sun, the ocean stochastic events, and the very design of the system, versus CO2 or whatever you want to call it. But every time there's a super El Nino, see that super El? Oh, wait a minute. I forgot I got the painter here. See that super El Nino? Woohoo! I figured out how to use that, all right? And you see this super El Nino? Notice what happened. This is the pause period, right? So these super El Ninos are so strong, they put a lot of water vapor in the air. And water vapor makes its biggest difference in temperatures where it's very cold and very dry. When someone says to you, oh, it's getting hotter, no, the daytime maxes across the planet are not going up. Nighttime lows are going up a bit. And that would just be because you've got more water vapor in the air. All right. If you look at something we call saturation mixing ratios, it's a big thing that weathermen use to look at stability. Okay. A lot of people think I'm unstable. I'm very buoyant. All right. And when something surprises me because I'm a meteorologist, that's why I say, oh, buoyant, instead of oh boy, oh boy. But in any case, the more water vapor in the air, okay, but think about it. I want you to think about this, okay? Put on your thinking caps, all right? All right, let me make sure that I'm thinking too, all right? What happens when it's 90 degrees and I breathe out? And by the way, there's 100 times more carbon dioxide in the air or in my breath than there is what I inhale, okay? So I'm a carbon polluting machine. I understand that. Okay. When I breathe out 90 degrees, nothing. But what if I breathe out where it's 30 degrees? You can see your breath. Now, why is that? Because condensation processes are quicker when it's colder. Where condensation processes are quicker when it's colder, what happens is what we see. It's actually snowing more in the northern hemisphere. But it also means more cloudiness, so it has to be clouds for snow, right? There's more cloudiness, and so it doesn't get as cold as it did before the Arctic during the winter. But the summer temperatures aren't going up. Now, I don't want to get bogged down here, okay? So it's not a cranberry thing. Get it? Cranberry bog? You could use that joke today. All right, so anyway, there's my step-up theory. Now, if you wanted to just say this, yes, you can. Yes. It's definitely warmer than what it was, right? But I think it's because it's water vapor shot into the air. I'm going to show you an example of this. These are global sea surface temperatures now, and they're pretty warm. And look at these really warm patches. Here's your El Nino. Let me just put that painter. El Nino, warm patch, warm patch, warm patch, warm patch, warm patch. This has turned much cooler than what it was. And of course, you have the cool ring in the Atlantic, and the El Nino, which is one of the reasons why I don't believe this is going to be like a big hurricane season as far as the deep tropics go. But all that warm water near the United States is in the story. Okay, I digress, whatever that means. Okay, so here we are in 1995. Look at how cool the oceans are overall, right? So what has happened in the last 20 years with water vapor? Well, the lowest levels of the atmosphere, it's increased like mad across the tropical areas. So you can see it actually dried out parts of the Pacific, and you see it increasing in the Atlantic basin. But here's what I want. Okay, hold on. Is that this working? Yeah. Look at that. Look at that. And look up across the north here, where there are relatively small increases in water vapor. Now let's see what the global temperature has done during that time, okay? We got those. Hardly any increase here, a little increase here in the tropical Atlantic, but look at across the Arctic. Look where the bulk of the warming is, and this is what they're not telling you, that it's a distorted pattern that between the Arctic Circle and the Antarctic Circle, it's warmed, but not that much. So if you're factoring in the Arctic, obviously it's always going to be warm in the winter seasons as long as there's a lot of water vapor in the air. And this last Super Nino just shot a lot of water vapor in the air again, and so we are warming. And that's my step-up theory. Where is that thing? That Super Nino, we stepped up here, there's your pause. Super Nino, we're in another pause here that's higher, all right? So we'll see. But I just wanted to show you that relationship, all right? You can see it's as plain as the nose on my face. Let's take a look at the nose at my face. You can see that, right? Okay, good. All right, good. Okay, so we got that down. So water vapor increasing and bigger temperature changes where it's coldest and driest, okay? It's not brain surgery. Now, what about the trapping hot spots in the tropics that would go just make the tropics feed back and boil over, all right? We issue boil warnings in the tropics, one storm after another, okay? Well, it's drying out up at 400 millibars. Why do we look at 400 millibars? Because it is we usually look at 500 millibars, but over the equatorial areas, because the tropopause is higher, okay, we look at that level a little bit more, and for where trapping starts to occur, or with hurricane development, we like seeing a lot of moisture at 400 millibars. So we have had no increase. So if you looked at the hurricane video yesterday, we've had no increase in the global ACE index. It's drying out over top. Now, what does that dry air mean? It means these storms, these storms have to work harder to become stronger if they have to get rid of dry air. All right, so the years where there's moist air around, you got to look out, okay? So that's something that we look at. There was a guy who I really admire, is Eric Blake at the National Hurricane Center. And I think he's on the other side of the global warming issue from me, but you know what? I don't get mad at people. They might get mad at me, but it's an issue by issue thing with me, But Eric is really a brilliant meteorologist. All right, I mean, he's just like one of these guys where he can communicate just moving his eyebrows like that, and people as smart as him can figure out what he's thinking. Anyway, that was like in that Sherlock Holmes movie I just saw. One of the worst movies I've ever seen. In a movie review, I can't believe Will Ferrell made that movie, Holmes and Watson. But there was a good part where they were communicating with their eyes. Okay, and I'm the dumb guy that can't do it. All right, now where was I? Well, I was where I am now, in the same place. But what I was saying was, I remember I was at a conference, and Eric was speaking, and he said, hurricanes are actually as massive as they get. They're sort of delicate as far as their development and how they can stay together. You need the right conditions. And a lot of times when you look at the atmosphere, folks, it will go to one thing, and then it'll go to the opposite thing. All right, we relied on that for last year for saying that those areas that were devastated in 2017 weren't going to have much down there in the Caribbean. We sort of think that's the same way this year. But I'm just saying that when you have a lot of dry air in the mid and upper levels of the atmosphere, up there at that level I was talking about, and you can see all that dry air at 400 millibars, it means two things. One, the trapping hotspot theory is not working. That's one. And two, it tends to suppress the increase in hurricane activity. All right. So this is sort of linked to yesterday in a bit of way. But what I wanted to really point out is I wanted to show you the relationship with water vapor, how it has increased so dramatically where, the oceans are warming over here, right? And the temperatures have not increased so dramatically in these areas, where a lot of people live. There are not a lot of people living up here. In fact, I just saw what was it on History Channel? These islands to the north of Norway that the Russians took over and were trying to build this great place. It's up in the Arctic, and it didn't work. It's a ghost town now. But it is warming up there, so maybe they're going to try it again. All right, you've had enough. All right. Sometimes I think I should apologize. I'm not really as politically correct as some people want me to be. And I'll tell you what, though. If you want to be politically correct, you don't say anything, all right? And it would be, I was once at this convention, right? And these guys that weren't talking were like communicating. It was a meeting of the mimes. You could use that joke today too. Above all, enjoy the weather. It's the only weather you got.